You spent 6 months breaking down a massive monolithic codebase into microservices. You deployed them, expecting a clean, scalable utopia. But instead, you ended up with a tangled, fragile mess that's somehow even harder to manage than the monolith you started with. Let's look at this diagram of a standard loan management system built on synchronous REST APIs. We have a loan service, a customer service, a credit service, and a notification service. In a purely REST-based architecture, these services communicate by tapping each other on the shoulder. Each service must interrupt the next and wait for a direct response before it can move forward. When a user applies for a loan, the loan service calls the customer service to check the profile. Then it calls the credit service to evaluate the score. Then it approves the loan, and finally it triggers the notification service. Because every step in this chain requires the previous step to finish, the entire operation is completely rigid. The speed and success of the application are entirely dictated by the absolute slowest link in the chain. Now, watch what happens when traffic spikes and the credit service experiences a sudden, unexpected slowdown. In this diagram, you can see what happens when the credit service takes too long to respond. Because the loan and customer services are waiting for that response, their threads lock up. Connection timeouts trigger. The slowdown cascades backward through the entire system. You might add retries, timeouts, or circuit breakers to stop the bleeding, but those are band-aids. They treat the symptoms of the bottleneck rather than curing the underlying structural disease. Splitting code into different Git repositories didn't magically create microservices. By keeping them tightly coupled through synchronous talls, you just built a distributed monolith that fails together. Moving code between repositories doesn't fix the underlying fragility. A real solution requires a change in how the system processes logic and manages communication. The first step is shifting away from thinking about database tables and starting to model actual business processes. This is the core of domain-driven design, or DDD. As we see in this diagram, DDD relies on ubiquitous language. This practice forces the codebase to reflect the exact vocabulary used by the business domain. Bounded contexts create boundaries, isolating domain logic, ensuring a credit score doesn't leak. Instead of row updated, DDD introduces domain events, capturing realities like loan created as immutable actions. By treating microservices as living representations of business events rather than dumb data stores, the architecture finally has the proper boundaries required for true autonomy. But to connect this new vocabulary, we need a different kind of plumbing. We need event-driven architecture. Think of event-driven architecture like a company chat channel. Information is broadcast asynchronously into a central data stream, available immediately to anyone who needs it. Let's rerun the simulation. The loan service drops a loan-created event into Kafka, moving on instantly. Credit and notification services pull the event independently. Let's simulate a credit service crash. The broker keeps running. The event waits safely until the service reboots. When you pair the strict business boundaries of domain-driven design with the asynchronous plumbing of event-driven architecture, you decouple your system. Instead, fragile chains become autonomous, resilient networks. Before you rewrite everything, keep in mind that not every minor database update justifies the complexity of an event message broker. You also have to plan for eventual consistency. It is perfectly acceptable for a user interface to display a pending status while asynchronous tasks resolve in the background. And synchronous REST calls are still highly useful. They remain the superior choice for simple, immediate data queries, where decoupling just isn't necessary. For your core workflows, the next time you design a feature, stop thinking in REST endpoints. Start designing them around meaningful business events. Take a look at your own codebase. Are your services talking too much? Let me know in the comments below, and share your war stories of blending DDD and